Hi, how's it going? In this video I'm just going to go through some simple formulae for you to do with sectors of circles, okay, involving radians. So this is a sector of a circle, there the origin of the complete circle, sometimes called the centre of the circle, okay. Traditionally is R for the radius and theta for the angle that is subtended by the sector of the circle, and the formula we are interested in are formula for the arc length, so that's an arc. That's the arc length, sometimes called the minor arc. The major arc will be the other bit of the complete circle. Area of the sector, that's the area of the whole of this sector. Remember, there's a minor and a major sector. This is the minor sector, the smaller part. The major sector will be everything else of that full circle. And area of a segment, okay, which we'll come on to afterwards. All using radians, okay. You need to use the formulae for radians with these, okay. Now, before we go on to that, let's just try and remember what we did in GCSE, okay? So I don't want to start with that. I want to start with the arc length. So the arc length, okay, in the GCSE, we worked out the arc length using this formula here, which I'm hoping you remember, okay? So we know that the circumference of a whole circle is 2 pi r, that is the whole complete turn is 2 pi r. And then what we did was we found what fraction of a circle we had, okay? So that was determined by the angle theta. So we did theta over 360 degrees multiplied by 2 pi r. And that gave us what the arc length was when we used degrees, okay? Now, using our conversion between degrees and radians, if you recall, 360 degrees is the same as 2 pi radians. So what I'm going to do is I'm just going to rewrite that as theta over 2 pi times 2 pi r. And notice how the 2 pi there and there can cancel. And you're just left with theta multiplied by r. And that is what our formula is using radians. It's just r multiplied by theta. How simple is that? How simple is that? Okay, one of the reasons why I prefer using radians, people. Okay, because it makes formulae like these a lot simpler to deal with. So all that means is, as long as you know what the radius of the sector is and what the angle subtended is, you just find the product, you multiply them together. That gives you the arc length. That's nice and simple, isn't it? Okay. Let's have a look at the area of the sector then. So for the area of the sector, similar thing in GCSE, what you did was you worked out what proportion of the circle you had, what fraction you had, and then multiplied it by pi r squared, because pi r squared is the area of the complete circle, okay? And so we did theta 360 times by pi r squared. Using the conversion between degrees and radians again, 360 degrees being 2 pi, okay? We can write it like this, and if we do some cancelling, that pi there can go and that pi there can go, and what we're left with is theta over 2 times r squared, or a half times r squared theta, okay? Half r squared theta. And that's our formula using radians for the area of the sector, okay? So that means is you square the radius, half it, and then multiply it by the angle, okay? And then done. You've got your sector area. The last thing is the area of the segment, okay? Now let's just talk about what we mean by a segment. A segment is when we join these two points on the sector, okay? And split it up into a triangle, and the shady bit is what we call the segment, okay? That's what we call a segment of a circle, okay? And so what we need to find is the area of that. And it's quite simple. I'm not sure if I'm going to fit it on, actually. You work out the area of the sector. I'm going to have to put it underneath, okay? Disadvantage of having a small board, okay? So it's sector area, and then we're going to subtract from that the area of this triangle, okay? So sector area, subtract area of triangle. And that is it. That's all we're doing. Now, we know the sector area in radians is that. We've just worked it out, haven't we? It's 1/2 r squared theta. The area of the triangle, remember what that is? Well, the common formula for the area of the triangle is 1/2 AB sine C, where the angle C is in between the lengths A and B. These will be the lengths A and B. Since they're both a radius, that will be 1/2 times r sine that angle there. And so we've got 1/2 r times r, which is r squared, sine the angle, sine theta. Okay. And that's it. Now, sometimes you'll see this in factorised form, which is fine. You can factorise it as 1/2 r squared, and then open the bracket, theta, subtract sine theta. Okay, that is it. That's all we're doing. Okay, if you can't remember that formula, do not worry. Do not worry. Okay, as long as you remember these two. Okay, because you can work out the area of the whole thing, the sector. Okay, and then once you've got that, you just, well, you need to remember the area of the triangle formula. Okay, you work out the other triangle, and then you just find the difference. Okay, so you don't actually have to remember that formula. If you do, it's helpful, but if you don't, as long as you remember the technique. Okay, so that's it. Those are the formula that you need to use to be able to work out arc length and areas of sectors and segments. Okay, I'm hoping you found that useful. Okay, I'll see you again.